In section 5.2, proving that lines are parallel, there are quite a few theorems that do indeed help us to prove that lines will be parallel to each other using exterior or interior lines. But before we do that, let's take a look at this triangle and a line extended from one of the sides. Let's first start by labeling each one of the angles as A, B, C, and D. There are a couple things we can conclude from this diagram by itself. We can conclude that A plus B plus C will equal 180 degrees, since there are 180 degrees in a triangle. We can also conclude that angle B plus angle D equals 180 degrees, since B and D are supplementary. Now, using a simple substitution, I can set angle A, B, and C equal to the summation of B plus D. From there, if I subtract B from both sides, you'll notice that they'll cancel out. Therefore, what I have is A plus C equals D. A and C are called the remote interior angles, since they're the angles opposite B and D, which line is being extended from. So what we can conclude is that the remote angles of a triangle equal the exterior angle of the triangle. What we also know is that each angle in a triangle has to be greater than 0. Well, if each angle is greater than 0, that would mean that angle D has to be greater than C, and angle D also has to be greater than A. That brings us to our first theorem. The measure of an exterior angle of a triangle is greater than the measure of either remote interior angle. So looking back at our diagram, angle D is greater than angle A, and angle D is also greater than angle C. Now to the theorems that prove parallel lines. The first one is, if two lines are cut by transversal such that two alternate interior angles are congruent, the lines are parallel. If we're given in this case, angle 3 is congruent to angle 6, since they are alternate interior angles, you can see that here and here, then that would conclude that line A is parallel to line B. We can shorthand this by using alternate interior angles that are congruent imply parallel lines. I'll be using the same diagram for the next following, so you can kind of use that in your notes instead of rewriting it each time. The next theorem is theorem 32. If two lines are cut by a transversal such that the two alternate exterior angles are congruent, then the lines are parallel. So in this case, if the given was angle 1 is congruent to angle 8, since they are alternate exteriors, then again, line A would be parallel to line B. Again, there are two pairs of alternate exteriors, so it could also be used for angle 2 congruent to angle 7, and that would also imply that the lines would be parallel. We can shorthand this with alternate exterior angles congruent implies parallel lines, just as we did with the previous. The next theorem is, if two lines are cut by a transversal such that two corresponding angles are congruent, then the lines are parallel. This time, the corresponding angles in this diagram would be 2 with 6, 1 with 5, 3 with 7, 4 with 8. If any of those are stated to be congruent, then again, you can imply that angle A is congruent to angle B. Again, we can shorthand this like the previous one. Corresponding angles that are congruent imply parallel lines. Theorem 34 is a little bit different than the previous ones. If two lines are cut by transversal such that two interior angles on the same side of the transversal supplementary, the lines are parallel. So in this case, it would be angle 3 supplementary to angle 5, or angle 4 supplementary to angle 6, which would prove that line A is parallel to line B. This is kind of a basic substitution to get to this theorem. We would know that 1 would have to be supplementary to 3 based on the assumptions in the diagram. And then since 1 and 5 then are on the same side and are corresponding, then it would imply the parallel lines. Again, you can shorthand this with 2 interior angles, same side of transversal, supplementary, imply parallel lines. Theorem 35 is very similar to Theorem 34, except for instead of being interior angles that are on the same side and supplementary, it is the exterior angles. Therefore, if 1 would be supplementary to 7 and 2 supplementary to 8, it would imply that lines A and B are parallel. Again, we can shorthand it just like we did in 35, except for instead of interior, we will use exterior. And finally, the last theorem for this section. If coplanar lines are perpendicular to a third line, then they are parallel. So if I know that A is perpendicular to perpendicular to C, and B perpendicular to C as well, then A and B would be parallel. Alright, let's look at a quick proof. Given the following, that angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 2, prove that ABCD is parallelogram. Parallelogram being defined as two opposite pairs of parallel sides. So in this case, I'm trying to get AB parallel to CD and BC parallel to AD. What you want to do in a lot of these cases when we're talking about parallel lines is just to extend all of the lines in the direction. Then you can see where where interior and exterior lines will be. As usual, we're going to start with our givens. From there, we can right away say that line BC is parallel to AD. If we have 2 interior angles on the same side of the transversal that are supplementary, that implies parallel lines. So we'll mark that with parallel line symbols, which is the double arrows. And again, that reasoning is because angle 1 and angle 2 are supplementary to each other. And you'll notice that they're on the interior right here of those 2 lines, which would then mean that these lines extended right there are going to be parallel. Now, knowing that angle 3 is supplementary to angle 2, you can see that those are supplementary on the same side and they're interior. So that will also lead to be AB parallel to CD based on the same reasoning. And again, once I have 2 opposite sides that are parallel, then I've established a parallelogram. So I can go right to the conclusion.